Hello friends, today we solve problem on graphical analysis. So let's start. So we already studied what is a graphical analysis. We study motion curve and standard motion curve. So here is a question. Question is, the race car starts from the rest and travels along a straight road until it reaches a speed of 42 meter per second in 50 seconds as shown in VT graph, velocity time graph. Determine the distance traveled by the race car in a 15 seconds. Draw position time and acceleration time graph. Okay, so they give velocity time graph here. So from 0 to 20 seconds, the velocity of vehicle keep on increasing with uniform rate, okay, and reaches at 18 meter per second. Then from time interval 20 to 30 second, from 20 to 30 second, the velocity is remain constant, means here the uniform velocity. Then from time interval 30 to 50 second, the velocity keep on increasing and the final velocity will be 42 meter per second, and they ask to draw position time curve and acceleration time curve, and also find the distance traveled by the race car in 50 seconds. So let's start the solution. Okay, so here we already studied this. Okay, so we have a VT curve. From VT curve we can find acceleration and the position of the particle. To find the acceleration, we have to just find out the slope on a curve, and if we have to find the position, then the formula is xf, the final position, is equal to initial position plus area under the curve bt. So we start with the acceleration. So here this is our motion. Okay, so let's start with the solution. So first we find the AT curve. For AT, so we have velocity time graph and we have to find the acceleration. To find acceleration, we have to just calculate the slope. Okay, so here the velocity for time interval 0 to 20 seconds, the velocity keep on increasing and reach at a 18 meter per second. So first we find out the acceleration from 0 to 20 seconds. Okay, so first acceleration from 0 to 20. Okay, so we have to just find out the slope. Okay, so we use 2-point form. Okay, so we require two coordinates. One coordinate here 0 0 and another coordinate is 20 comma 18. So we get two coordinates, that is x1 y1 is 0 comma 0 and x2 y2 is 20 comma 18. So we have to find just slope. So we know the formula using 2-point form, that is y2 minus y1 is equal to x2 minus x1. If we substitute this value, we get answer, that is 18 minus 0 divided by 20 minus 0, and we get the answer is 0.9 meter per second square. So here the velocity is, change in velocity is uniform, means rate of change of velocity is uniform. It means that the acceleration is a constant. Okay, so from 0 to 20 second the acceleration is constant and value will be 0.9 meter per second square. Okay, 0.9 meter per second square. So now next we find out acceleration between 20 to 30 seconds. Okay, the acceleration for 20 to 30 seconds. So here the velocity is constant and the line which is parallel to x-axis is having slope is equal to 0, means here acceleration of the particle is 0. So now second, from 20 to 30 seconds. Okay, line is parallel to x-axis, therefore slope will be 0, is meter per second square. Okay, this is our third answer. Our third, here from 30 seconds to 50 seconds, velocity keep on increasing with constant rate. Okay, so here rate of change of velocity is constant, means acceleration is also constant. So we have to find the acceleration for this line. Okay, so we use just if we find the slope of this line, we get the acceleration. Okay, so we have to just find out the slope using 2-point form. So acceleration from 30 to 50. Okay, the value using 2-point form, y2 minus y1 upon x2 minus x1. So here x1 y1 is 30, 18. Okay, and y2 will be 50, 42. Okay, so 42 minus 18 upon 50 minus 30. The answer is 1.2 meter per second square. Okay, this is our last answer. But in question they ask draw 80 graph. So we get the acceleration for time interval 0 to 20 seconds, acceleration from 20 to 30 seconds and 30 to 50 seconds. We have to just plot graph. Okay, so let's plot a graph, 80 graph. Okay, so here it is a uniform acceleration because the rate of change of velocity is remain constant. Okay, and for time interval 30 to 50, rate of change of velocity also constant, so acceleration also uniform. So let's draw the graph. Okay, so we get the value 0.9 and maximum value is 1.2. So for time interval 0 to 20, the value of acceleration is 0.9, which is uniform, means it is a positive value of slope, the straight line for 20 up to 20. Okay, then for time interval 20 to 30, the value of acceleration is 0. The graph will become this. Okay, then for acceleration from 30 to 50, it is uniform, means it is a constant line. So we get acceleration time graph. So in question they also find to draw xt curve. So we have to find the position using vt curve. So we have a VT curve and we have to find the position of the particle. Then the formula is xf is equal to final position of the particle is equal to initial position of particle plus area under the curve Vt. Okay, so xt curve, our next heading will be. Okay, we know the formula, that is xf is equal to xi plus area under curve V. Okay, let's find out the position at each point. Okay, when t is equal to 0, the initial position of particle also they also mention starts from origin. Okay, starts from rest. So initial position of the particle at t is equal to 0, x will also equal to 0. So here first at t is equal to 0, x naught will be 0. Okay, second, now we find out directly at 20 seconds. Okay, not at 10 seconds, directly find out. Let's find out at 20 seconds. Okay, that t is equal to 20 seconds. Okay, the initial position will be 0, we consider 0. Okay, we have to find the x20, that is the final position. Okay, the formula is final position is equal to xi plus area under the curve Vt. So x20 is equal to 0 plus area under the curve Vt. So we have to consider this area. We have to consider this area. So it is a triangle and the area of triangle is half into base into height. The base is 20 and height is 18. So we get 1 by 2 into 20 into 18. So we get x20, the position of the particle at time 20 seconds is equal to 180 meter. Okay, so we get position of particle when time is 20 seconds. Now let's find out the position of particle when time is 30 seconds. Okay, so next, and at time t is equal to 30 seconds. So we find out the x20 is equal to this position of particle when time is 20 seconds is 180 meter. Now find out the position of particle when t is equal to 30 seconds. So x30 is equal to xi, initial position. So here we consider initial position is x20. Okay, which is 180 meter. Then we have to consider time interval is 30 seconds. Next time interval. Okay, so x30 is equal to xi is equal to x20 plus area under the curve. So we have to consider area after 20 seconds because here our initial disposition will be x20. If we consider initial position if x naught, then we have to consider this amount of area. Here we consider x20 as a initial position, so we have to consider area after the 20 seconds, means we have to consider this area. So it is a rectangle. The formula for the rectangle is base into height, means here time interval base is 10 and height is 18. So 10 into 18. The answer will be 180 plus 180, which is 360 meter. Okay, this is a position of particle when t is equal to 30 seconds. Now we find the position of particle when t is equal to 50 seconds. So next, fourth, at t is equal to 50 seconds. T is equal to 50 seconds, and we have to find x50. So our formula is xf is equal to xi plus area under the curve vt. So we have to consider xi first. So I take xi, initial position of particle, as x30. Okay, so then we have to consider area after the x time interval 30. Okay, so we have to consider this amount of area. So here xi is equal to 360 meter, which is x30. Okay, x30 will be our xi. So we have to find x50. So x50 is equal to x30 plus area under curve. Okay, so x30 is 360 plus here area under the curve. So here we have to find this area. So if we divide this area into two parts, okay, part 1, part 2. So part 1 is a triangle and part 2 is a rectangle. So if we add these two area, we get the total area. So here area under the curve will be A1 plus A2. Okay, then 360 plus area of part 1. Okay, it is a triangle. Okay, the area of triangle is half into base into height. Base will be 50 minus 30, which is 20, and the height is 42 minus 18, not a 42. Okay, height will be 42 minus 18. This is the height of the triangle, that is 42 minus 18, and base will be 50 minus 30, which is 20. Okay, so A1 will be half into 20 into 42 minus 18, which is area of section 1. Now we have to find the area of section 2, and we just add, we get the total area. The area of section 2 will be, it is a simply rectangle, so base into height, base is a 20 and height is a 18. Okay, if we solve this, we get answer becomes 960 meter. So we get our final answer, that is the position of the particle when t is equal to 50 seconds, which is a 960 meter. So they asked to determine the distance traveled by the race car in a 50 seconds. So answer will be the 960 meter, that is the distance traveled by race car in 50 seconds equal to 960 meter. Okay, but in question they asked to draw xt curve. Okay, so we have to draw xt curve first. So position in meters, time in second. Okay, time is 0 10, 20, 50 and maximum is 960. Okay, so we have to plot a graph for xt curve. Okay, so we already studied this uniform velocity motion, uniform acceleration motion curve, standard uniform acceleration motion curve. Okay, so we have this graph here. It is a VT curve. Okay, VT curve, if a straight inclined line with uniform velocity, uniform acceleration motion. So here, if we see here in this motion, velocity is rate of change of velocity is constant if it's an inclined straight line, then the x will be parabolic in nature. So for time interval 0 to 20, if it is an inclined straight line, then the displacement curve will be parabolic in nature. So from 0 to 20, the displacement of the particle is 0 to 20, displacement of the particle is 180 meter. Okay, and the nature of curve will be parabola. So we just draw parabola. Next, from 20 to 30, velocity is constant. So velocity is constant means in this graph it is a uniform velocity motion because velocities remain constant. If the velocity is straight line, horizontal straight line, then the displacement graph will be the inclined straight line. Okay, so from for 30, the graph nature is straight line again. Okay, so from 30 to 50, velocity, rate of change of velocity is constant. So if we see the standard motion curve, here velocity is inclined, then the graph of the displacement is a parabolic in nature. So we draw just parabola. Parabola with the increasing nature, not a decreasing. So we get final answer, that is xt is equal to xt curve, that is we get plot a graph. So we find out the distance traveled by the race car in 50 seconds, that is 960 meter. We plot a graph x and t, and we also plot a graph for the acceleration time curve. Okay, this is our final answer. Thank you. If you find my videos are helpful, then please like, share and subscribe our channel. Thank you.